evaluate this double integral over the region D, where D is the triangle with vertices 0 0 origin 2 1 and 0 1. So basically we have this region, okay, and this is y equals 1. This line has equation y equals 1, and this passes through 0 0 and 2 1. So let's find the equation of this line. Okay, passes through the origin, so y equals mx plus b, that b is 0, no y-intercept, and slope is rise over run, so this is 1, just 1 rise and 2 run, so 1/2. Slope is 1/2, so y equals 1/2 x. Okay, and this is type 1 region because we have lower curve y equals 1/2 x and upper curve y equals 1. So we can convert this double integral as an iterated integral, as follows. So inside first y is 1/2 x to 1, and we have the same function x is square exy, so y first, dy then dx, and this arrow, if you look at closely, we can take anywhere from 0 to 2, so x runs from 0 to 2. Okay, let's do this integral inside first. So x from 0 to 2, inside we want to integrate with respect to y, so x is squared, that remains as a constant. Exy, we have y, so it's like e raised to 2y, you can think in that way because the x is constant. So antiderivative of exponential function itself, and we need to divide by this constant, in this case x, and we want to evaluate this for y equals 1/2 x, lower limit to 1, and dx. So that is outside, still x equals 0 through 2. Now plug in y equals 1, that's the upper limit. By the way, x square x, we can cancel one copy. Okay, then replace y by 1, so this is x e raised to y equals 1, so just x, that's the upper limit part, minus lower limit x e raised to x times y is 1/2 x, x times 1/2 x. Okay, 1/2 x times 1/2 x is 1/2 x squared, e raised to 1/2 x squared, and now we need to integrate with respect to x. Okay, so here, oh, this is function of x, same thing, function of x. So here is a product, so ex and ex, product means we need to use integration by parts. Here x times e raised to 1/2 x squared. What is the derivative of 1/2 x squared? Just x, that's what we have. So for this we can use u substitution. So let me write this as an integral of 2 separate. So x from 0 to 2 of x times ex with respect to x, minus 0 to 2 x times e raised to 1/2 x squared with respect to x. Here we need to do integration by parts, and as we know, integration by parts is when we have u dv, that's uv minus integral v du. Okay, using that, in this case our u is, let me do it separate here, let u be x and dv be ex dx. So du is derivative of x is 1, and antiderivative v is just ex, and uv minus integral v du. So this part is, in fact, now we can write this is same as uv, so x times ex, and we go from 0 to 2, minus integral v du ex times 1 dx, just ex dx. Okay, minus for the second integral, because 1/2 x squared, its derivative is just x. We have that. We did not have that situation here. So this will be our u, and its derivative x dx will be du. Okay, so let me just do that in my head. This is u, derivative is x dx, with respect to x dx will be du. So this integral is same as now the minus in the front side, integral e to the e raised to u x dx is du, but the limits 0 and 2, those are for x. Now our new variable is u, so we need to convert. So when x is 0, so this is our assumption, so when x is 0, u equals 1/2 times 0 squared, just 0. And when x is 2, 1/2 times 2 squared. 1/2 times 4 is 2, so this will be 2. Okay, let's evaluate this. Upper limit is 2 e raised to 2 minus lower limit 0 times e0. E raised to 0 is 1, but 0 times 1 is just 0. You don't have to write, so 2e squared minus integrate ex, which is itself, and we need to go from 0 to 2, minus same thing here, eu, just eu, and we need to go from 0 to 2. Okay, this is same as 2 times e squared, which is a decimal number, by the way, minus upper limit e raised to 2 minus, but there is negative in the front, so plus e raised to 0, which is 1, minus same thing, in fact, e2 minus, but due to negative, plus e0 is 1. So this is final, but we can just simplify a little bit. 1 1 2, oh, 2e squared minus e squared minus e squared, oh, they cancel, negative e squared negative, just 2 copies of negative and 2 copies of positive, so just 2 final.